So taking the next step with composite functions, we're talking about how to solve problems with them. And so the biggest thing is trying to remember that to compose functions, you use the output of the first function as the input for the second function, so that every value is returned as an output for the first function must be an acceptable input for the second function. So what that's saying is if my first function was f of x equals x plus 1, and my second function was the square root of x. Well, if I plugged in negative 7 for x, negative 7 plus 1 is going to give me negative 6. And if I tried to put that in g of x, it wouldn't work because I cannot take the square root of negative 6 without using imaginary numbers. It's not going to give me a real answer. So we've got to, as part of using composite functions, we have to figure out what our domain and our range are. So our domain and range of the original functions determines the domain and range of their composite functions. In a composite function, the range of the first function must match the domain of the second. So for a number b to be in the domain of a composite function, g of f of x, the input b must be in the domain of f of x, and the output f of b must be in the domain of g of x. So putting this all together, we have this problem here. F of x equals 2 minus x, g of y equals square root of y, and g of f of x equals the square root of 2 minus x. Truly, when I'm finding the domain, the only thing I have to worry about is my composite function, the square root of 2 minus x. There's a couple things that limit our domain. So first of all, if I have the square root of something, I'm going to put a circle there, then that something must be greater than or equal to 0. Second of all, if I have a denominator, I'm going to put a box there, that denominator cannot equal 0. That's really our only two limitations. So what you see here is you see the square root of 2 minus x. So that means that 2 minus x has to be greater than or equal to 0. Because I cannot take the square root of something that's negative. I mean, I can, but I have to use imaginary numbers. I don't get real answers at that point. So we're only going to be worrying about numbers that are 0 or bigger. So I'm going to solve this for x. I want x's on one side, my number's on the other side. First thing I'm going to do is subtract 2 from both sides. So negative x equals negative 2. And I'm going to divide both sides by negative 1. So x is now less than or equal to positive 2. The reason it's less than or equal to is because whenever I divide by a negative sign, I always switch the direction of my inequality sign. If I divide by a negative, I switch the direction of the inequality. So my domain has to be x's that are less than or equal to 2. So for this next one, I have f of x equals the square root of x minus 5. G of y equals 1 over y. So g of f of x equals 1 over the square root of x minus 5. So I have a couple things here. First of all, I have a square root symbol. So I know that whatever's underneath the square root symbol, which is x, has to be greater than or equal to 0. It's the first thing I know. The second thing is I have a fraction and I have a denominator. So that means that the square root of x minus 5 cannot equal 0. So this first one I don't have to solve. That's about as good as it's going to be. My second one I do need to solve, so I pretend like that do not equal sign or cannot equal sign is really just an equal sign. And I'm going to add 5 to both sides. So I get that the square root of x equals 5. to get rid of a square root sign, I need to square both sides of my equation. The square root of x squared is just x, and 5 squared is 25. So what I now have is that x cannot equal 25. So what that means about my domain is I know that it can be anything bigger than 0, except it tells me here it cannot be negative, it cannot be 25. So we say that our domain is all real numbers greater than or equal to 0, except for 25. So that it can be 0, 1, 2, 3, 4, all the way up to 24.99999. It cannot be 25, but it could be 25.0000001, 26, 27, 28, all the way to infinity. And it would be able to be plugged in. The problem is if I plugged in 25, then my denominator would be 0, and I would get an undefined answer because we cannot mathematically divide 1 by 0. And I can't use anything negative because I can't take the square root of anything negative. So for number 1, I'm supposed to find the domain of g of f of x. So it's a square root. That means whatever's underneath the square root must be greater than or equal to 0. So I'm going to solve that for x. I need to subtract 1 from both sides. So x must be greater than or equal to 1. And that would be my domain. For number 3, I have f of x equals x plus 3. G of y equals 5 square root of y. And g of f of x equals 5 square root of x plus 3. Again, what's underneath the square root symbol must be greater than or equal to 0. So I'm going to solve for x. I'm going to subtract 3 from both sides, and I get that x must be greater than or equal to negative 3. I don't have to worry about that 5 that's in front because that 5 I'm just multiplying by whatever number I get when I take the square root. The big deal is that whatever's underneath the square root, like in problem 5, 10 minus x, must always be greater than or equal to 0. So if I solve this, I'm going to subtract 10 from both sides. So negative x is less than or equal to, or is greater than or equal to negative 10. And then I'm going to divide both sides by negative 1. So remember, when you divide by a negative, you flip the direction of the inequality sign. So x becomes less than or equal to positive 10. And that would be our domain. I'm actually going to go ahead and do number 8 here. So number 8, I have a denominator. That means whatever is in the denominator cannot equal 0. So I solve it for x as if it was just like an equal sign. So I'm going to subtract 1 from both sides, so x equals negative 1. So what that means is that for this particular problem, x can be any number except for negative 1. So I would write that as all real numbers except negative 1. All real numbers except negative 1. And number 9, I have f of x equals x plus 6. G of y equals 2 over the square root of y. So g of f of x equals 2 over the square root of x plus 6. Well, I know what's in the underneath the square root symbol has to be greater than or equal to 0. I also know that what's in the denominator can't equal 0. Well, since what's in the denominator and what's under the square root are really the same thing, rather than saying x plus 6 has to be greater than or equal to 0, I'm just going to say that x plus 6 has to be greater than 0. Because it can't equal 0 because the square root of 0 is 0, and then my denominator, I would have 2 over the square root of 0, which would be 2 over 0, and that's going to give me an undefined answer. So rather than just saying greater than or equal to 0, because the square root is in the denominator, so because just the square root is in the denominator, looks like this, 1 over the square root of blah, 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 then I can say that the blah, blah, blah part just has to be greater than 0. That's it. So I'm going to solve for x. I'm going to subtract 6 from both sides. So x has to be greater than negative 6. As long as x is greater than negative 6, I'm going to come up with an answer.